Good morning, good afternoon, and good evening, everybody. My name is Filip Černý. I'm the product marketing manager at Progress Software. And today we're going to look together at a webinar called IT and OT Convergence, Defending Critical Infrastructure, and how you can proactively do proactive threat detection for industrial control systems. Before we deep dive into the topic, let's go through some basic housekeeping rules. In your navigational panel, you have a question mark button, which allows you to submit all your questions. So anytime throughout the webinar, don't hesitate to ask any question. We do have a dedicated time at the end of the webinar to answer them. For those that we don't have enough time to answer, we will follow up with you in the email. This webinar is being recorded and you will receive a recording in the follow-up email as well. If you can't hear us, please also check your audio button or try to reconnect your headset. I believe that is it. So let's now dive into the topic. Let's see. Okay, so IT and OT world. To understand IT and OT difference and how they converge, let's look at the evolving relationship between the two. So first, on the left, we have the IT, informational technology. This is the world of the data and the digital communication. It's where most of the cybersecurity efforts have traditionally been focused on. And on the right, we have the OT, operational technology. So this is the domain of physical processes, the machine, the sensors, and the control systems that keep factories running, water flowing, and power grids stable. Historically, these two worlds were separate. OT systems were isolated, often running on proprietary protocols, and was the most important air gapped from the internet. But that is no longer the case. Today, digital transformation, remote work, and efficiency demands basically are driving IT and OT to converge, meaning that the OT world is now connected to the internet as well. And while this brings operational benefits, it also introduces new vulnerabilities. OT systems, which were never designed with cybersecurity in mind, are now exposed to the same threats that plague the IT networks. This convergence is why we need a new approach to security, one that understands both sides of the equation. So let's go deeper uh, into the OT world. Uh, Now that we talked about the convergence, let's break down some of the terminology that is often used in the space. So first, OT, operational technology, is the broadest term. It refers to the hardware and software that monitors and controls physical devices and processes. You can think of it as the nervous system of industrial environments. Within OT, we have something which we call ICS, industrial control systems. These are the systems that manage and automate industrial operations, like controlling valves, motors, or sensors in factory and power plant. And within ICS, we can have, for example, SCADA, supervisory control and data acquisition systems. SCADA systems are specific type of ICS that gather data from sensors and devices in real time and allow operators to control them remotely. So in short, SCADA is a subset of ICS and ICS is a subset of OT. Um, let's take a moment and look at where OT lives in the real world. So these are not just abstract systems; they are the backbone of our daily lives. OT is what keeps the power grid running, ensures clean water reaches your homes, keeps transportation systems moving, and manages the flow of natural gas, for example. These systems are often invisible to the public, but they are absolutely essential. And because of their importance, they become a prime target for cyber attacks. A single disruption in any of these sectors can ripple across entire regions, affecting millions of people. For example, imagine the power grid is suddenly going offline due to a cyber attack. Hospitals will lose power, and backup generators fail under extended use. Traffic lights go dark, causing widespread accidents and gridlock. and millions of people are left without heating or cooling during extreme weather. Uh, Transportation systems example, if we imagine that, for example, a ransomware attack disables a city rail signaling system. Trains are halted mid-route, standing thousands of commuters. Freight shipments are delayed, disrupting supply chains. Emergency services are delayed due to traffic chaos. From a natural gas infrastructure example, if we imagine a cyber attack shuts down a gas pipeline in winter, homes and businesses lose heating during freezing temperatures. Industrial operations grind to a halt, causing economic losses, and panic buying and pricing spikes ripple through the energy market. And lastly, water management. If we imagine a hacker alerts the chemical dosing in a water treatment plant, for example, drinking water suddenly becomes unsafe, triggering a public health emergency. Entire cities are forced to rely on bottled water, straining supply chains, and public trust in those services then collapses. So these aren't just hypotheticals. These are real risks we've seen play out in various forms around the world, and they underscore why securing OT environments is not just IT concern, but it's a matter of public safety and national resilience. So why are OT environments such a high-value targets for cyber attacks? First, they're often underdefended. Many OT systems were designed decades ago with little or no consideration for cybersecurity. They are running out on outdated operating systems, they can't be easily patched, and often lack basic protection like encryption or authentication. Um, Secondly, the impact of a successful attack is massive. Unlike IT breaches that might result in data loss or financial fraud, attacks on OT can cause physical damage, service disruption, and even threats to human safety. Let's look at a few motivations behind these attacks. Thefts of intellectual property, like proprietary manufacturing processes or control algorithms. It can be sabotage by hostile nations, alerting water treatment levels or shutting down the power grids. It can cause a maximum disruption at low cost. A single breach can affect millions of people. For example, the recent EPA report found that the drinking water systems servicing over 193 million people in the United States are vulnerable to cyber attacks. And that represents nearly 60% of the populations of the whole country. So it's the implications and the impact is enormous. Um, Here is the paradox that we're facing. Industrial systems, our ICS and SCADA environments have evolved significantly, but they are now more connected, more automated, and more data-driven than ever before. But their cybersecurity hasn't kept up. Many of these systems are still running on outdated operating systems. Some can be even decades old. A great example is something like an MRI machine. It's a multi-million dollar piece of equipment that might still be running on an really updated Windows XP operating system or a Linux, for example. These systems were never designed to be connected to the internet, but now, for the sake of remote access, monitoring, and efficiency, they are. And that opens the door to attackers. And the result? We have a highly valuable, highly vulnerable system exposed to modern cyber threats without the defense to match it. This is why visibility and proactive detection are so critical. We can't rely on traditional perimeter defenses anymore. We need to know what's happening inside the network, and especially in these legacy environments. Let's take a look at what happened when OT systems are actually compromised. One of the examples I personally like is the Stuxnet example from 2010. The world witnessed one of the most sophisticated cyber attacks in history, and the malware, which was called Stuxnet, was specifically designed to target centrifuges at Iran's Natanz nuclear facility, causing them to spin out of control and physically destroy themselves. It was the first known cyber weapon to cause real-world damage. Uh, In the end, the attack was discovered by cybersecurity researchers after it spread beyond its intended target. Iran eventually replaced the damaged centrifuges, and the malware exposure led to global awareness of the OT vulnerabilities. So this marks possibly the first cyber attack that impacted the OT world. But we don't need to go further away from another examples. If we fast forward to 2021, we saw the Colonial Pipeline ransomware attack. This incident disrupted fuel supply across eastern United States, causing panic buying, price spikes, and even flight delays. The company responded by shutting down operations and paying roughly $4.4 million in ransom. However, US law enforcement later recovered a portion of the ransom paid by tracking the Bitcoin wallet used by the attackers. So, still, in this case, although the ransom was partially recovered, it still highlighted the impact such attack can have. And I even remember deep diving into this specific scenario, and even the attackers were actually helping the organization restore the operations, stating that they are in the money making business and not the making people's harder business. But let's move on. Uh, Now let's talk about the real world challenges organizations face when trying to secure those OT environments. First, these systems were never designed with cybersecurity in mind. Many are decades old, and endpoint security is really difficult to enforce because you can just install an agent or antivirus on a PLC or patch a legacy HMI controller without risking downtime. Second, there is often a complete lack of network visibility. If you can't see what's happening on your network, you can't detect threats or respond to them effectively. Third, security processes and design are often missing or are outdated. OT teams prioritize uptime and safety, while IT teams focus on data and access control. This crucial divide makes it hard to implement unified security strategies. And to that, the convergence of IT and OT, and you get a perfect storm. Systems that are rarely patched, equipment that's obsolete but still mission critical, and environments where prevention alone is no longer enough. That's why we need to shift our mindset. We must assume that prevention will eventually fail and focus on detection, response, and visibility as core pillars of OT security. So we know that prevention will eventually fail. Out of all the examples that you can now find on the internet, I bet that all of the attackers are aware of your firewalls in place or are aware of your perimeter defenses, and they still manage to get through sophistication methods, social engineering, phishing, and so on. So, what happens when prevention fails? Well, unless you have some second layer of defense of monitoring and detection capabilities to be aware and respond to those threats, you're pretty much on your own. You are unaware, and you don't know, you have no way of finding out that you even are under attack until it's too late. So this is why I would bring forward our solution, Flowmon, Flowmon Network Detection Response platform that gives you deep visibility into the network traffic, whether it's in the cloud, on premise, or in hybrid environments in the IT world, or in your OT environment. It's designed to detect anomalies based on the behavioral change, prioritize threats, and help you respond with confidence to support your and then help you respond with confidence. And it supports the full cybersecurity lifecycle. So you can detect threats or early indicators of compromise by AI-powered threat detection. You can have a full visibility into your IT and OT network, and you can then respond to possible incident and indicators of compromise when you come upon them. So imagine having a tirelessly high-skilled network security analyst working for you 24/7, never sleeping, never missing a communication flow, never missing a packet, and constantly learning. That's what Flowmon delivers. Flowmon uses AI-powered analytics to monitor your network in real time, detect anomalies, and prioritize threats. It's not just about collecting data, it's about turning those data into actionable intelligence. And here is where Flowmon solution can stand out. You can have advanced threat detections where we distill thousands of raw alerts into a handful of meaningful security incidents so your team can focus on what truly matters. You have real-time insight that shortens the time to investigate and respond to attack, helping you act before the damage is done. You have full observability across your IT and OT network through one centralized view. And with smart prioritizations, where the solution connects the dots between seemingly unrelated events and those early indicators of compromise to give you what you should focus on next, and allows you to automate analytics, so it reduces the burden on your security team by automating complex investigations. So in short, the solution empowers your team to do more with less noise, less guesswork, and more confidence. So if we look at the architecture, it's quite simple. If we start from the middle, you have one centralized device that we call Flowmon Collector. Flowmon Collector takes the network telemetry data from your infrastructure, from your routers, switches, firewall, and we can even deploy our own sensors when necessary for deeper visibility and provide that centralized observability across the full environment. The whole solution can be hardware or virtual. We support all the major platforms, whether it is in cloud, in AWS, Microsoft Azure, or Google Cloud Platform, or in hardware or in virtualized environments for VMware, Hyper-V, and KVM. So once you have the solution deployed, you can have full visibility across your traffic and run our anomaly detection system modules or other modules. It's just a simple software extension on that we install on the collector, and we can have that AI-powered threat detection engine or triggering full packet capture for deeper forensic analysis, or this is specific for IT, measuring application performance. So one of the biggest challenges in securing OT environments is the diversity in protocols in use. Uh, these aren't your typical IT protocols. They are specialized, often proprietary, and not well understood by traditional security tools. Flowmon is built to bridge the gap. It supports a wide range of ICS and SCADA protocols, which includes the IEC 104, COAP, Goose, MMS, or DLMS. And with that, we have deeper visibility into those environments. And also, the added value is the capability of monitoring those environments with our sensors, which I mentioned on the previous slides. So with Flowmon Probe, we can take a full copy of your network traffic and generate that enriched network telemetry data, allowing us to understand your environment and provide further analysis. It's highly scalable from 1 gig networks to 100G networks. It uses unsampled export data and provides visibility across level 1 to level 7 and capable of capturing the full packets when necessary. So let's look at an attack scenario, how it would go. So this scenario is mapped to a MITRE ATT&CK framework, which helps us to understand the tactics and techniques used at each stage. What's important here is that each step leaves a trace, a change in a behavior, an anomaly that that deviates from the baseline. It can be an unusual login, for example. So Flowmon is designed to detect these signals early, correlate them, and alert you and your team before the attacker reaches the OT environment and can cause further damage. So this is why visibility across both IT and OT teams environments is so critical. You can stop what you cannot see. So we have an attacker. who will pick a victim and then attack scenario. He will craft a spear phishing email campaign and gets initial access to the network. Once he's in the network, he can take over an account and gain a position. Now, escalating privileges, he will get a privileged account, establishes a connection with command and control server, and expands horizontally across the environment, trying to spread laterally. He can collect the data about the company's operations and take over as an administrator. Well, this will give him the admin rights to compromise the OT firewall and configure and pivot to the OT environment. And that once he is in there, he can exfiltrate critical and sensitive data, but he can also disrupt the SCADA operations. So uh, control the valves, for example, in some systems, or switch off the cooling mechanisms so the power plant will overheat, or for many of other examples. So this is how an attacker would normally proceed, but each of these steps can be detected and provide early indicator of compromise to a security team who can then respond so it doesn't get to that final impact stage. Um, this diagram brings everything that we discussed into one single unified view. So we have an IT world where we have our cloud platforms, routers, switches, firewall, virtualized platforms, and we have our OT world as well. Well, with the deployment of Flowmon Probe, Flowmon sensors, we can collect raw network traffic data from those components. We can send that enriched network telemetry to one collector, where we can then analyze those data. But we doesn't need to rely on the centers alone. We can leverage the existing infrastructure. Most of these components already have the capability to export network telemetry in some or format or another. So Flowmon Collector can ingest from various sources in the various formats to provide you that depth of visibility. And then it's just a matter of user access and giving you the visibility into the data from an observability point of view or from a security point of view. That gives the great insight for the network operations center team from a monitoring perspective, and you can even feed the data to some higher form of security tools like CM in your security operations center. So this is one of the most important takeaways from today's sessions. You cannot secure what you cannot see. In today's complex environments spanning cloud, on-prem, and OT systems, visibility is everything. Without it, threats go undetected, incidents escalate, and responses times lag. Flowmon provides a single source of truth across both IT and OT environments. It allows you to detect threat actors early before they can cause damage, see every packet transferring your network and not just summaries. You can identify indicators of compromise in both IT and OT. You can minimize the breach impact by reducing the dwell time and accelerating response. You can correlate events to reduce noise and focus on what truly matters. And you can empower your team. Even a junior analyst can conduct complex investigations with confidence. So this is the main benefits of the Flowmon solution. And I would like to now show you an example. This is one of our customers. It's This organization operates a large-scale network that directly impacts over 1 million households and businesses. It's an electrical grid company. It's called EGD, and we have a nice statement from the head of cyber and physical security management, Martin Kep, and he states that the operational condition of our network has a direct impact on more than 1 million households and businesses in our territory. And immediately after the deployment, the system helped us identify several misconfigured devices. Thanks to the insight the solution provides, we can see all our traffic in one place and are immediately warned about any emergent or potential issues that may arise. It provides us with information on network usage, pinpoints potential bottlenecks, exposes network-borne threats, and reports on a variety of network traffic anomalies. So this was a large-scale deployment where we deployed more than 90 monitoring probes at key points of the network infrastructure, and also in combination with collection of network telemetry from existing routers. This whole monitoring and anomaly detection system was integrated with the CM system the organization had in place. So we were feeding the data to one centralized SOC basically, and we supported for specific protocols, basically specific to OT environment, and they're capable of covering not just the local network, but the OT infrastructure as well. So this is one of the examples how solutions such as Flowmon can provide value to organizations, help them stay ahead of the new threats that arise. So I've come across, I've come to the end of my presentation. I would like to close it with a proposal. If you found any of this interesting and thinking of a possibility to monitor your environment and scale to the capability of network threat detection and response, contact us. We are happy to provide you with a short demonstration of our product. We can help you understand, we would like to understand your challenges and help you design the solution so it can provide the value regardless of your environment. And you are happy to try the solution free of charge for 30 days. The solution is quite easy to deploy and we can guide you throughout the whole process. Um, so this is the end of my presentation, and let's now move towards the questions. Let's see if there are some. Uh, so again, you have your navigational panel, and there is a question mark icon. So if you have any questions, you can submit them there. And I can see a question. How does Flowmon detect threats in OT environments where traditional endpoint protection isn't possible? Well, this is what we've covered. So we don't rely on any agents. We use network-based detection. So by analyzing the communication flow, we basically apply behavioral patterns across the network. So by a combination of, I think more than 200 algorithms, we basically apply different techniques like machine learning, adaptive baselining, heuristics, complementary with signature-based detection and threat intelligence. We are capable of recognize when there is a potential behavior that is not normal, that is abnormal, and can be a sign of potential cyber attack. So that's how we do this. Uh, we have another questions. To trial Flowmon for 30 days, do we need additional hardware? It depends. So simply no, we can provide you the hardware, the Flowmon probe and Flowmon collector ourselves. You can then without support deploy it, so you don't need any specialized hardware. If you would like to continue, if you would like to trial the environment in a virtualized form, we can provide you with the license, and you need to have your virtualized environment in place and assign some computing powers to it. We do have specs sheets for that, so that's also for some and easier options. Uh, Next question. How your solution detect threats within OT? You have specific methods in place. Can you list them? Um, Maybe I would leave this to let's say one-on-one conversations, we do have specific methods, like I mentioned, adaptive baselining, heuristics, machine learning, signature-based detection, and threat intelligence. And we also complement these approaches with our own proprietary technology, which we call behavior patterns. So this allows users, customers, to create their own metadata detection, their own detection methods on the metadata level. So even a specific detection based on your environment, we can create some customized detection for that as well, or your customers can. And those detections are also shared on community. So we have a wide range of the methods, but pretty much we know the great benefit is that we know what the normal behavior in the network looks like. So then it's not easy hard to spot the anomalies, the early indicators of compromise. So looks like there is no more questions coming in. So thank you again. I hope that you found the topic useful and on all the answers provided. Uh, if you'd like to get in touch with us, please visit our website progress.com/flowmon, where we have all the contact forms and all solution briefs, demos, and everything available. So reach out to us. We'd be happy to engage with you. Thank you, and I'll be looking forward to the next topic with you. Have a nice day. Goodbye.